Today we're going to continue our study on circles by talking about arcs and circumference. So first let's talk about circumference. So the circumference of a circle is the distance around the circle. How do you find the circumference? Well, the circumference is found by multiplying pi times the diameter, or 2 times pi times the radius. D would be the diameter, R would be the radius of the circle. So here's a picture for ourselves. C, the circumference, that's the measure around the circle, and you can find that either by finding pi times the diameter or by finding 2 times pi times r. Take a look at example 1. Part A, find the circumference of a circle with a radius of 9 centimeters. Well, to find this, we're going to need to use 2 pi r because we're given the radius. So that would be 2 times pi times 9, which would be equal to 18 pi. Now using a calculator, you can find an approximation that would be around 56.55. Right, part B. Find the radius of a circle with a circumference of 26 meters. Now this time you're given the circumference and you want to find out what the radius of that circle is. So we'll still use the same formula, but this time instead of plugging in for the radius, we want to plug in for the circumference so that we can solve for the radius. So this would be 26 equals 2 pi r, and dividing both sides by 2 pi, we have 26 over 2 pi. Now if you put that in the calculator, please do make sure that you have both 2 and pi in the denominator. I would suggest putting 2 pi in parentheses before you actually hit enter on the calculator. This should come out to be about 4.14, so the radius is about 4.14 meters. Okay, take a look at example 2. Use circumference to find distance traveled. So the dimensions of a car tire are shown at the right. To the nearest foot, how far does the tire travel when it makes 15 revolutions? Alright, so looking at this picture here, we see that the dimensions given are that we have 5.5 inches for the thickness of the wheel at the top, 5.5 inches for the thickness of the wheel on the bottom, and then 15 inches in between. Now, if I needed to figure out what the circumference is, which I do need to figure out, we would have to find the diameter, which would be 15 plus the two 5.5s, and that comes out to be 26 times pi, which is 81.68 inches. Now, this problem is asking you to determine how far the tire travels when it makes 15 revolutions. Since the circumference is 81.68 inches, and if it makes 15 revolutions, that means we're trying to find what 15 times the circumference is. Remember that one revolution is going to be the circumference of the circle. So the distance traveled is 15 times 81.68, which comes out to be 1,225.2 inches. And if you wanted this in feet, that would be about 102 feet. So the tire would travel approximately 102 feet in 15 revolutions. Now that we've talked about circumference, we're going to move into talking about arcs. So there's a corollary called the arc length corollary. And in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. This is actually telling us a proportion. One ratio is equal to another ratio. So this says the ratio of the given arc to the circumference, so the arc over the circumference is equal to the measure of the arc over 360 degrees. So here's what this is saying. So let's say we're trying to determine this red part, AB here. That arc length divided by 2 pi r divided by the circumference of the entire circle is equal to the measure of that arc. Now when we say the measure of the arc, that's different from arc length. Remember, measure of the arc is referring to the degree measure. Arc length is referring to the measure if you were to take a ruler that bends and measure what that distance is from A to B along the red line. Now, another way to write this, if, for example, you're trying simply to find the arc length is to multiply both sides by 2 pi r, and that would give us that the arc length of arc AB is equal to the measure of arc AB over 360 degrees times 2 pi r. Let's look at some examples. So in part A, you're trying to find the measure of that red arc AB. So the arc length is equal to the measure of that arc, that would be 60 degrees, over 360 degrees, that's the whole thing, times 2 pi r, times the circumference. Now what is the circumference? It's 2 times pi times 8, because 8 is the given radius. So that comes out to be 8.38 centimeters. You can also think of this as what you're really doing is you're finding the circumference and you're finding that fractional part of the circumference, right? So if the circumference is 2 pi times 8, you want to find the portion, the fractional part of that circumference that is accounted for. And you know that that fraction is 60 over 360, or 1/6 of the entire circle. Let's look at part B. We're trying to find the arc length of arc EF. And again, we have 60 degrees here, but the arc length is not going to be the same as in part A because the circumference of this circle is different. It should be longer. So this would be 60 over 360 times 2 pi times 11, which comes out to be 11.52 centimeters. You can think of this as finding 1/6 of the circumference, but this circumference is longer than the circumference of the first problem. All right, in the last one, you're finding the arc length of arc GH. And again, we'll do 120 over 360. We'll find that that's equal to 1/3. So we're finding 1/3 of the circumference, which is 2 pi times 11. And so this would be 23.04 centimeters. You'll also notice here that this is exactly twice part B. And you'll notice actually both circles are the same because they have the same radius, 11 centimeters. But the arc length is different. So arc EF took up 1/6 of the circle, whereas arc GH took up 1/3 of the circle. So it is exactly twice the length of arc EF. All right, example 4, use arc lengths to find measures. So in this case, we are, instead of trying to find the arc length, we're actually given the arc length here. So looking at A, circumference C of the circle Z is what we're trying to find here. So I would start off by writing the proportion that we had written before for this corollary. So the arc length of arc XY over the circumference, so it's always a part to a whole, is equal to the measure of arc XY over the whole circle, which is 360 degrees. Now let's substitute what we know. So we're told that the arc length of XY is 4.19. We're trying to find the circumference C, and we know that the measure of XY is equal to 40 degrees. Now to solve for the circumference, we can try to simplify. I'm going to simplify the right-hand side. That's equal to 1/9, so we can work with some easier numbers here. Cross multiply, and we get that C is equal to 37.71. Let's look at part B. So here, we're trying to find the measure of arc RS. So we're trying to find a degree measure. Again, I'm going to start by writing down that proportion. So remember, it's always a part to a whole. So we'll start with the arc length of RS over 2 pi r, which is equal to the measure of RS over 360 degrees. Now let's substitute what we know. The arc length of RS is 44 meters, as is told to us in this diagram. We also know the radius is 15.28, so that would be 2 pi times 15.28 for the circumference. And then we're trying to solve for the measure of arc RS. Now to get the measure of RS by itself, I can multiply both sides by 360. And solving that, again, if you want to put this all in the denominator in the calculator, just be sure that you have 2 pi times 15.28 all in parentheses, so that when you divide in the calculator, it divides by all of those numbers. You should end up getting that the measure of arc RS is about 165 degrees. All right, here's our last example for today. The curves at the ends of the track shown are 180-degree arcs of circles. The radius of the arc for a runner on the red path shown is 36.8 meters. About how far does this runner travel to go once around the track? Round to the nearest tenth of a meter. Okay, so let's look at the path of this runner. We're looking at the red path here. What is this path? How would you describe it? Well, there are 2 straight sections and then 2 semicircles. So if we're trying to find the total distance, we're going to need to find the sum of the lengths of all those parts. So the distance is going to be 2 times the length of the straight section plus 2 times the length of each semicircle. Now, we're told that the length of the straight section is 84.39. And then to find the length of each semicircle, well, a semicircle is going to be 1/2 of the circumference. What's the circumference? It's 2 pi times, and if we look how far out it goes to the red line, it says 36.8. So 2 pi times 36.8, and then half of that, because we have semicircles, but then we have 2 of them. So it's really going to be 2 times 1/2 times 2 pi times 36.8. So the 2 and the 1/2 will end up canceling each other out. So 2 times 84.39 plus 2 pi times 36.8 comes out to be about 400 meters. So the runner on the red path will travel about 400 meters.